Okay, in this video, we're going to find the domains of all these three functions, and hopefully you guys have seen part 1 already, because I went over the three conditions that we need to know whenever we're trying to find the domain. So if you haven't already, be sure you guys go check that out first. Anyway, let's do the first one. Notice that we have two things to worry about, because the first one is we do have a fraction, and the second thing is we do have a square root. And let's do this inside out. So I will pay attention to the square root, especially just the inside. We know that inside of the square root cannot be negative. In another word, I want to make sure, and that's once again write down, make sure, the inside of the square root, which is x minus 5 in this case, it has to be non-negative, in another word, greater than or equal to 0. And this is how we can set up an inequality to give the condition on the x for the function. And from here, you can just add the 5 on both sides, and you get x is greater than or equal to 5. That's pretty much it. But this is just the first condition. The second condition is that because we have this fraction, we have to remember we cannot divide it by 0. So I will pay attention to the bottom right here, and I'm going to make sure the second thing is the denominator. This time, we have to write down the whole thing, namely 1 minus square root of x minus 5. I want to make sure that the whole bottom right here cannot be 0. And then from here, once again, you can solve for x. And then you can just go ahead, minus 1 on both sides. So you get negative square root of the x minus 5 not equal to negative 1. And then we can divide both sides by negative 1. And then we see this is x minus 5 instead of the square root. This cannot be equal to positive 1. And then we can square both sides. So they cancel, and we get x minus 5 cannot be equal to 1 squared still 1. And lastly, add a 5 on both sides. We are saying x cannot be equal to 6. So as you can see, we have the first and the second condition now. And this is it. But finally, we have to know how to present our answer. And in my opinion, whenever you have this kind of situations, try to use interval notation. And before that, try to make a graph so you can see what exactly is going on. So I will show you guys a graph right here on the side first. Let me draw a number line. And from the first condition, we know that x is greater than or equal to 5. So let me mark here and say this is 5. And because x can be equal to 5, I will put a closed circle here. And because it's bigger or equal to, so I will just move to the right like this. So that's the first condition. However, the second condition says x cannot be equal to 6. So I'll go right here, and then let me just erase this right here and say this right here it's 6 with an open circle. So this is the graph for the domain for this function. And finally, for writing down the answer, I will be using interval notation this time. We have two pieces. The first interval, we have 5 and 6 for the endpoints. Let me put on 5, 6 like this. This right here, we're including the 5, so let's put on a bracket, but we are not including the 6. So let's put on parentheses. And then here's the second piece. We are going to use union. We don't use the word or in the interval notation. All right, so let's put on union 6 and all the way to the right. So it's 6, infinity. We are not including the 6. So parentheses, we can never include infinity. So parentheses, and this right here is the domain for the first function. Okay, for the second one, we have g of x, square root of 2 minus another square root of x plus 3. So 2 square roots. So we have to make sure two things happen, right? Okay, from here, do the inside one first. Inside of the inside. From here, let's go ahead and say, let's make sure that this inside, namely x plus 3, we have to be sure this is greater than or equal to 0. And then from here, subtract 3 on both sides, we get x is greater than or equal to negative 3. And then we are done, right? Nice and easy. Now, we have another square root. So this is also the inside of the bigger square root. We also have to make sure the second things that happen, we have to write down the whole thing this time. So this is 2 minus square root of x plus 3. This is the whole inside for the bigger square root. And we once again have to make this greater than or equal to 0. And then from here, you solve for x again. Minus 2 on both sides first. So we get negative square root of x plus 3 is greater than or equal to negative 2. I'm just subtracting 2 on both sides. So I don't have to change this. Next, I will have to divide both sides by negative 1. This time, because we divide both sides by negative 1, so it becomes square root of x plus 3. But I will have to change this to a less than or equal to. And then you work this out, you get 2. And then from here, what shall we do next? Of course, we can just square both sides. And of course, on the left-hand side, the square and square root cancel, and we just get x plus 3. But here is the technical part. When we square both sides, and because the output of the square root, this is always positive. Likewise, this too is of course positive. When you square both sides of the positive numbers on both sides, the inequality stays. So you maintain that to be less than or equal to. Let me give you an example. So imagine if you have a negative number right here, and let's say 2 right here on the other side. Of course, we know 2 is bigger, so it's less than or equal to, right? And if you square both sides, on the left-hand side, you get 16. On the right-hand side, you get 4. But you have to switch it sometimes. This right here is troublesome because one of the numbers is negative. So you might have to do more investigation. But this right here, we can be sure you just keep the inequality because you can just write it down somewhere on the side, maybe like this. Since square root of x plus 3 and 2 are both positive. So you can just maintain the inequality. So it's nice in this case, unlike this one. Anyway, 2 squared is 4, and then x plus 3 is less than or equal to 4. Minus 3 on both sides, we get x is less than or equal to 1. So we have 2 conditions again. And an easy way to combine these 2 conditions is, of course, use a number line. So we will use it again. First one, we have x is greater than or equal to negative 3. So let me say this is negative 3 here. Close circle, and then we are going toward the right. This is the first condition. And the second condition says x has to be less than or equal to 1. Let me mark it here and say this is 1 with a closed circle, but this time we are going to the left-hand side. So as you can see, we have to pick the overlapping region, which is just this. So finally, the domain is from negative 3 to 1. So that's it. Just negative 3 to 1. Both including the endpoints. In another word, if you plug in 2, unfortunately, it's not going to work because it's outside of the domain. If you plug in negative 7, it's not going to work for this neither, right? And of course, we are not talking about imaginary numbers when we're talking about real functions. So this right here is the domain. And we have one more. This right here, ln function. And we only have the ln situation, so it's just one condition that we need. Just the inside. And in this case, we have to make sure the inside, which is x squared minus 2x minus 3, is what? For the ln, for the logarithm, you have to just make sure it's greater than 0. We cannot have 0 anymore. And then from here, this is slightly trickier because it's a nonlinear inequality. So the way to solve it is that I would recommend you guys to factor this first. And let me just put down x plus 1 and then x minus 3. And you still maintain the greater than 0 like right here. But next, do not just say x plus 1 is greater than 0 and then x minus 3 is greater than 0. It's not like this. As I said, it's pretty tricky, so don't do it like this. And if you want to see more detail about how to solve this, you can check out my other video. But this is how I recommend you guys to solve. From here, I will tell you guys there are 2 numbers that we care. So let me just put down, here are the 2 numbers that we care. I care about -1 and +3. Now, how do we know? You first make the first factor, x plus 1, you make it equal to 0. And secondly, you make the second factor equal to 0. So, of course, from here, you can just subtract 1 on both sides. So you get -1. And secondly, you get 3. So these are the two numbers that we care. And it's similar to what we have done earlier. Seriously, whenever you are trying to solve a nonlinear inequality, the safest way to do it is by using a graph along the way to help us out. So we will do the graph again. A number line, and we have -1 here and +3 right here. These are the two numbers that we care. But because the original inequality here, I don't have an equal sign. Even though I care about these two numbers, but I don't want to include them. Therefore, I am going to put an open circle here and an open circle here. I care about these two numbers, but I don't want to include them. All right? This is that if you are a parent, well, so maybe later on, you have kids, and the kids become adults. They turn 18. You will tell them, hey, I care about you, but I don't want to have you in the house anymore. No, just kidding. Anyway, get back to math. Now we have 1, 2, 3. 3 pieces, and you have to be sure you pick the right piece. And to do so, once again, the safe way to do it is you pick a number that's less than -1. Plug it into this inequality with this one. Test it out. So let me just pick a number that's less than -1. Let's say I want to test x is -2. Plugging into here, I think it's easier. And let me just show you guys the work one time. Plug in -2 and then +1 times -2 minus 3. And do we get greater than 0? Yes, because this is -1 times this is -5. Of course, this is +5 greater than 0, so this is good. And in that case, you just color, you just shade this part. You just go to the left all the way. Next, you pick a number from -1 to 3. Let's say 0. And you can do this in your head if your teacher doesn't mind, or if you're just in a hurry or whatever. But anyway, this is the work. Now I will just show you. If you plug in 0 into here, 0 plus 1 is 1. And then plugging 0 into here, of course, you get -3. Altogether, you get 1 times -3 is -3. It's not greater than 0 anymore. So it's false. Then you go to the next one. And of course, you pick a number that's bigger than 3, so you can say x is equal to 10. As long as it's bigger than 3, it's okay. 10 plugged into here is 11. 10 plugged into here is 7. 7 times 11. 711. No. Anyway, it's positive for sure. You just work that out. And then the most important part is you have to pick this piece. So this is just like the dirty work that you have to do. That's all. So 2 pieces again. Finally, here is the domain. First piece, all the way from the left. So that's -infinity up to 0. No, this is not 0. Up to -1. And this is the test value, so you don't worry about this, right? So it's the number you care, which is -1. You cannot include -infinity, so parentheses. We don't want to include -1, so parentheses. And the second piece is from 3 to infinity. So put on union, 3 to +infinity. And with that, we are done.